In this video, we will learn how to create an integrated library in Altium. So our integrated library will contain the schematic symbol just like this capacitor, the PCB footprint, and also the 3D visualization like this. So it will contain everything related to that component, and we can easily drag and drop the component from our integrated library to our schematic to our project to create a new PCB project. So let us begin. Go to the file menu, click new and select project. And in the previous video we have selected a PCB project, and in this video we have to select an integrated library project and choose a name for your library and the location and hit OK. And for example, in this video I am going to teach you how to create a symbol, footprint and 3D model for a component called a MOV. So this one is an MOV, and this MOV stands for metal oxide resistor, and this is a circuit protection component. It is a simple 2-pin component just like a resistor or capacitor. And to properly organize all our components in the library, we will store this component in its own library, and we will call this library a MOV library because it will contain all of different MOV that we will deal with. So let us name this library MOV. And I keep all my Altium libraries under a folder called my projects and then Altium and libs. So here resides all of my libraries, and we'll check this option, that is create project folder. So it will create a folder named MOV for this project, and it will keep all the associated files inside this folder like this. Click OK. And here we go, we have a new project here in our project explorer, and currently it is not having any documents. Now let us add our very first document to this project. Right click like this, add new to project, and begin with a schematic library. So this schematic library will contain the schematic symbol like this, just as you can see here. It is C for a capacitor, a non-polar capacitor or a ceramic capacitor that is not having any polarity, and these black things called pins where connections are made. So it is composed of this graphic image and the pins. So we have this editor here. Just make sure our grid is 10 like this, but we have to edit this thing. This is the default name for this component, and this is component 1, which is not that much descriptive, so we have to improve it. And here we go, this will open this dialog. This is a very important dialog, and here we have to put default designator. So what is this designator? Because in our schematic sheet each component has a designator like C1, C2, C3, and in the similar way resistors have R1, R2, R3, and diodes have D1, D2, D3. These are called designators. So you have to put a standard or a descriptive designator. So what should we call? We can call this MOV, just like R. So if in the case you are making a capacitor, you will put something like this C, but you have to put an important symbol here, and this one is the question mark. So this question mark is a placeholder, and it will be actually replaced by a numeric value like C1, C2, C3 during compilation time of the schematic. But during the development of the library we have to use a placeholder like this one is a placeholder, the question mark, and you can make it visible or invisible. We will see what is the effect. And what is the comment? Here we have to put the comment. So generally we put a part number here. So today we are making this one, this part for this, the circuit protection of this DC to DC converter, and here they are using this MOV, that is S20K30. So this is the part number. We will put this in the default comment. And in case you are making capacitor, resistor, diode, so better you should put the value here. For example, if it is a 100 ohm, then you can put something like this, 100 R. If it is a 10 UF capacitor, put something like this in the comment. Right now we are putting this one for MOV, and then put a description, good description here, so that you are able to locate this part easily in your library. So this one is a 30 volt MOV, and something like this descriptive, and something 2000 ampere peak current, and this is in a 20 mm dia disk type. So something like this description you should put, so that during design of your schematic you will easily be able to locate the voltage, the current rating of this MOB, and easily drag and drop it. Okay, and in the reference component symbol reference also put this one, that is the part number of this component. And here are some extra parameters, we will see it in an advanced lecture when we will move to advanced PCB design. And this one is the model. So model is right now not ready, so this model correspond to this 3D model and also the 2D footprint. So right now it is not ready, that is why we will leave it blank. So when we will create the 3D model and the PCB footprint, then we will choose it here using the add button like this. So I think it is okay. Now we can hit OK and just save the document for safety and put a descriptive name here, MOV. So this library, this integrated library will contain all our MOVs, that is metal oxide varistors. Great. Now we have this component, we have this description. So see how nice it looks. The part number, the description, 30 volt MOV, 2000 ampere peak current. So it is very easy to drag and drop from the library. And now what we have to do, we have to design the actual graphical layout of this component. So before we can begin drawing, we need to know how does the symbol of a MOV look like, because this one is the symbol for schematic. So for that you can consult Google or you can consult any textbook for the proper diagram. So here you can see how a MOV looks like. So it is just a standard symbol, it's just like a rectangular thing and this cross thing. So we have to draw it like this. During drawing you need to be aware of the scale, you should not draw it too large or too big. So generally you have to consult a library first. So just open up a standard library that I have provided, for example this XBasic, and edit the symbol for this capacitor or any resistor. So get the idea of scale. So let me open one of this. So here is my XBasic library that contains all basic electronics components on my this file system, my hard drive. And here I have to open the project file, and the name of the project file is intlib. So where it is, lib package, lib package. I think this one is the integrated library project, lib package. So we have to open this one. So here I have opened this project. This one is also an integrated library project, XBasic, and here we have this schematic library, SCHLIB. So just open this up, and from here bottom we just go to the schematic library, and you will find all the components that are inside this library, that is XBasic, which contains all the basic electronic components. So just see here we are having a ceramic capacitor. So you can see these, all these light graph lines, these corresponds to 10 unit. So you can see that this is 1 2 3 30 unit long only, and approximately I think 20 units wide. So you have to draw something in the scale of this thing, that is 30 units, something like this. Otherwise your parts will look too big or too small when put on a schematic sheet. Great. So let us also inspect LED also, or a resistor, better is the resistor. So here we are having a resistor. Control plus mouse wheel to zoom in, zoom out. So here you can see this one is having one block, 1 unit, 2 unit, 3 unit, 4 unit. So this is 40 unit wide. So obviously the resistor is bit long compared to a ceramic capacitor on a schematic sheet, that is why this is 40. So you have to draw something in this range only, that means 20 unit wide, or 20 unit tall and 40 unit wide, something like this. So let us go to our own library and start the drawing. So let us first place, so also please take care about this origin. This is the origin where this x and y axis meet. So draw around this only, it is better to draw around this. Either put the corner of a pin here or the center here. Okay, so if we put first, let us put a pin. So this is only a simple component having only two pin. So go to the place menu and this time place a pin here. Place menu, then a pin. So this is a pin, and hit tab on your keyboard to open the properties of this pin. So this is the pin properties dialog box. The first and the foremost is this display name. So in case of simple components like this resistor, capacitor, MOV, we need to have a name. So this name will also be pin number 1 and the designator will also be 1, and both of this will be hidden for simple components like resistor, capacitor. We don't have pin number and designator shown here, so just make them invisible like this. And type, put passive. These are passive pin, no description is required. And one thing you have to make sure here, the length is 10. By default it is having I think 30 or 20 length by default, but this is too long for a pin. We don't need this long pin, only 10 is good for simple components like resistor, capacitor, and everything else looks good. And put the pin like this, and here you have to make sure that this crosshair, not this crosshair, this small crosshair here should be is the connection point that we have already discussed in the previous video where we were designing the schematic sheet. So this is the connection point, and we will put, and just press space to rotate this pin like this 90-degree each time, and place this crosshair in the origin. So this is the point where wires will get connected. It looks something like this. It will be having this dot dot like of thing, and this is different. Here connection cannot be made. This is the passive side and this is the active side. Actually it will be having some dots like this, so make sure. And we have, now we need to draw the body of this MOV. For that, just go to place and rectangle and draw a rectangle like this. So we will match this to the register. I think register was 2 or 3 units. Now we need to decrease the grid a bit. So always place the pins in 10 mil grid, and you can free to put this graphical elements at any grid. Okay, so let us reduce the grid by pressing the G key on the keyboard. Now my grid is 5. Now let us reduce this to half, like this, like this. Now much better. I think this is okay. Let us compare it with, yes, looking similar, or otherwise we can make it much thinner if required. So again we need to change the grid to 1, not 10 but 1. 1 2 3, 1 2 3. So this is looking much better, I think, much similar compared to this resistor. Now let us put the second pin, but before that change the grid to 10 by pressing G key. Great. Place again a pin. Now rotate. Now this time this crosshair like this. So both the connectable side or the active side of the pin should be outside like this. Like this. The dots should be here. If you place it like this, you will not be able to make proper connection because you have to put wire here and it will look very ugly. So this one is the correct orientation. Now we have to complete the graphical thing, and we have to put a line like this. So again we can change the grid to 5 and then place line, and 5 is also too much. Let us change to 1. How was the symbol? Like this. So I think this is looking like a MOV, but you can change the colors also if you need. So my this element is looking something like this. So let us change the outline. Where is the outline? This one is the fill color, this is the border color. So border was something like this blue, I think, and it was thicker also. Border width putting small. Great. So now they are looking similar. Just save it. Now that our schematic symbol is fully ready, it's time to compile this project. And to compile an integrated library, we need to go to the project menu and select compile integrated library like this. So as soon as you compile this library, Altium will also automatically install this library here. You can see it is installed. Just like all other library, we now have our this library, that is mov.schematic library. Okay, but this library is still not complete because it is not having the PCB footprint and the 3D model that we are going to create in the coming lecture. But before that, let us first test this symbol by placing it into an actual schematic. So this time just open a PCB project or a schematic project. So let me use the recents menu to open this project, that is the relay board project that we were working previously. And this is just for test, we don't need a MOV here in this schematic. I'm just opening this PCB project because we cannot put this thing, that is our newly created symbol, in an integrated library project. We need a PCB project for that. And just as any other library, now this time let us select MOV. Great, and we have a single component here in this integrated library. But before, we were using libraries like xbasic, which was having many components in it. And you must already be knowing how to place a symbol from library to your sheet. It is very simple, just a drag and a drop. So here we have our MOV. So scale is also looking good. And now let us try connecting it, place wire, by using the place wire command, and this is P followed by W, or using the place menu, place wire, already discussed in the previous tutorial where we were creating this schematic connection. So connection is also going great. Both side we are able to connect just like a standard component. Now let us put a resistor here and see the scale. A capacitor, so it's up to the scale, not too big or too small. Ooh, a resistor, great. Just a simple problem that this is thicker, this is thinner, so it is much better if both looked same. So what to do now? Now again go to your integrated library project, this MOV project. Just increase it a bit, a unit here, a unit there. I think now it's good. Go to this tab, that is schematic library, and our single component in the package. Now just right click on it and select this option, that is update schematic sheet. So it will update all schematic sheet where we have already placed this component. It will prompt update one component in one document. Select OK, and now go to this sheet. Now you can see that the register and our MOB are great, same size, same scale. So this way you can update a component on a schematic sheet after you have already placed it there. So this is a great utility. Now that our component is fully tested, we have already created the schematic symbol. Now in the next step, in the next tutorial, in the next lecture, we will learn how to create the footprint and the 3D symbol. So stay tuned, see you there.